Why can a camera flash release a huge burst of light instantly? Why does your phone stay alive for a second even after you pull the battery? And how can a tiny electronic component store energy without using any chemicals? That's the job of a capacitor. Take two metal spoons and place a thin sheet of paper between them. Don't touch them together, just bring them close. If you rub a balloon on your hair and bring it near one spoon, the other spoon reacts too. Energy is being held between the plates even though nothing is touching. That simple setup is the heart of a capacitor. This is the Learning Studio, where we explain electronics without the clutter. A capacitor is just two metal plates separated by an insulator. One plate collects positive charge, the other collects negative charge. And because the charges can't jump across the gap, energy builds up in the electric field between them. The bigger the plates, the more charge you can store. The smaller the gap, the stronger the electric field. The material in between, called the dielectric, decides how well the capacitor can store energy. A dielectric isn't just a blocker. It actually increases the capacitor's ability to store charge by reducing the electric field inside it. This lets the plates hold more charge for the same voltage, meaning more stored energy. Different dielectrics give different behaviors. Air, basic and cheap plastic, strong and stable ceramic, used for tiny high-speed circuits. Electrolytic materials store huge amounts of energy for camera flashes, power supplies, and audio systems. When a capacitor charges, energy gets stored in the electric field. When it discharges, all that energy can come out in a fast, sharp burst, far quicker than any battery. That's why capacitors are everywhere. They smooth voltage in power supplies, keep robots stable during sudden power drops, help phones survive tiny interruptions, and let camera flashes release intense light instantly. And here's the part students always overlook. Capacitors don't store electricity. They store energy in an electric field, and that energy is released the moment the circuit gives it a path. Now think about this. If capacitors store energy in electric fields, what happens when charges start flowing continuously instead of just being stored? That takes us directly into current electricity, the backbone of every circuit.